Suppose we have an elevator hanging by a cable. For now, we'll neglect any contact with the elevator shaft. We'll just assume it's fully suspended by this cable. And right now, this elevator is moving upward. So it's moving upward, speed v, and it's speeding up. So it also has an acceleration. Okay. So let's identify forces and then draw a free body diagram to organize those forces and understand this. Okay, so I draw my circle around the elevator, and I see one contact point. I see just the cable connecting. And so there is a tension force pulling it up, and then my long-range force of gravity. Okay. So having correctly identified, I don't see any other contact points. It's not moving fast enough for air drag to be a concern. I don't see any other contact points. And so now I'm going to relate these two forces, these only forces that are existing in this problem, on a free body diagram. Okay, so I've got this free body diagram. To do that, I represent the object of interest, my elevator, as a dot, and I draw a coordinate system. Now it makes sense to have just a standard coordinate system. Here's x and y, right? And then I can draw the force vectors on that. Now sometimes you'll have multiple forces pulling up or pulling down or left or right, and so you can offset them to clarify them, but noting that they are all acting on that object. Okay, in this case I have just two simple ones, and I'm actually going to offset them just so they're not confused with my axis lines. And so I've got a tension force pulling upward, right, pulling upward, and I've got gravity force pulling downward. Now, if it's accelerating upward, how big is my gravity vector? How big is that gravity vector? Is it bigger or less than the tension vector? Okay. If it's accelerating upward, the net force must be upward, which means the tension must be bigger than my force of gravity pulling downward. So this vector is bigger than this one, such that the net force is up, and therefore my acceleration is up. This is the way we take our understanding of forces and relate them to the acceleration.